This is Unit 7, Lesson 2 on reflecting parabolas. Reflecting functions across the x and y axes are an important mathematical processes that will be explored in this lesson specifically for parabolas, although the general ideas apply to all types of functions. So let's take a look at these transformations. All right, the parabola f of x equals x squared minus 6x plus 5 is shown on the grid below. All right, consider the function g of x equals negative f of x, and determine a formula for g of x and graph it on the grid below. Okay, now according to this, says g of x is the negation of what f of x is. So g of x is equal to the negation of what f of x is. And f of x is x squared minus 6x plus 5. So if I'm negating that, that's going to give me g of x equals negative x squared plus 6x minus 5, because the minus carries through the parentheses. Okay, so let's graph this. So let's grab my calculator. In the y equals, we want to put negative x squared plus 6x minus 5. And I'm going to go to graph it, and it's going to look like that. All right, so I want to find my vertex. My vertex is going to be at 3, 4. Let me check my graph here. My vertex is at 3, 4, 2, 3, 4, 3, and you can see right here the vertex is right here. So when I graph this, I have 3, 4 is my vertex. 1, 2, 3, 1, 2, 3, 4. And then we had 2, 3, and 4, 3, and my other points were 1, 0, and 5, 0. Okay, so 1, 0, and 5, 0 are right here. And when I graph these, I can see that this is going to end up being 2, 3, 4, 5. Looking like this. Now what happened to this parabola? Okay, what happened to the parabola? It reflected over the x-axis. Now that makes sense when you're thinking about it. Remember back in geometry, we did transformations of functions. What was the rule for reflecting in the x-axis? Well, when you took the point xy, you kept the x and you negated the y. So this becomes x negative y. So when we negate f of x, we are actually negating the y. All right, so when you're negating f of x, the entire function, you are reflecting over the x-axis. Okay, let's try another one. Now consider the function h of x equals f of negative x. Determine a formula for h of x and graph it on the grid above. All right, now h of x, we know, is going to be f of negative x. What are we negating this time? We are negating the x. So if I take my original function and define h of x, I'm going to take my function f of x and negate all the x's. So this becomes negative x squared minus 6 times negative x plus 5. All right, now watch your signs when you do this. Negative x quantity squared to be negative x times negative x would be x squared. Negative times a negative is a positive 6x plus 5. So h of x will equal x squared plus 6x plus 5. So if I go back to my calculator, I'll leave the other one in there. I'll do this one as the red one. So I'm going to put in x squared plus 6x plus 5. And if I go to my graph, all right, so I want to find my vertex first of all. All right, so my vertex should be at negative 3, negative 4, and then I have the values on the other side. So if I go to my graph, flip back here, let me do a different color so we can tell. All right, negative 3, negative 4 is going to be my vertex. 1, 2, 3, 1, 2, 3, 4. Oops, wrong way. 2, 3, 4 will be right there. And then these points would be right here. And then these points would be here. And those points would be here and here. Okay, so what happened to this parabola? How was the graph transformed? So it became this. All right, how was the graph of f transformed to first graph of h? It reflects in the y-axis. And again, that makes sense when you think about it. The reflection in the y-axis rule says when you have the point xy, you negate the x, but keep the y. So that's what we did right here. We negated the x. So if you negate the x, the y stays the same. It's going to be a reflection in the y-axis. So, in general, reflecting functions in the x and y axes. The function negative f of x, basically you're negating the y, is a reflection in the x-axis. The function f of negative x is a reflection of f of x in the y-axis because you're negating the x. Alright, so this works for any type of equation. What if we did a linear equation? Determine an equation for the linear function g of x equals 5x minus 7, both after reflection on the x-axis and a y-axis, and label your equation. Okay, so let's do a reflection on the x-axis first. If I reflect to the x-axis, if I take 5x minus 7, alright, what am I going to do to the coordinates? Well, when I reflect on the x-axis, I negate the y, which would be the negation of g of x. So if I negate g of x, that means this is going to be negative, parenthesis, 5x minus 7. And that will be negative 5x plus 7 if I reflect it in the x-axis. So this will be the equation, y equals negative 5x plus 7. Okay, now if I reflect it in the y-axis, if I reflect in the y-axis, that means that I take my function and I'm going to negate the x. So this is going to be g of negative x. So I take my equation, wherever I have an x, I put a negative x. Oops, minus 7. So 5 times negative x is negative 5x, and then minus 7. So my equation will be y equals negative 5x minus 7. So you can reflect either of the functions. You can write the equation if you know how it works, what to do with the function when you reflect. Exercise 3. If a parabola has the equation f of x equals 2x squared minus 3x plus 8, which of the following represents its equation of reflection in the x-axis? Okay, reflection in the x-axis means we negate the y. So this is actually going to be negative f of x. So we want to negate this entire thing. So negative f of x will be negative, parenthesis, 2x squared minus 3x plus 8. So this will be y equals, distribute the negative, negative 2x squared plus 3x minus 8. So which equation is this going to be? It is going to be number 2. Okay. After reflection in the y-axis, the quadratic function g of x equals 4x squared minus 7x plus 2 would have the equation what? All right, if we're reflecting in the y-axis, we negate the x. So this is going to be f of negative x. So I take this function and I put in negative x into each one. So g of negative x will be 4 times negative x squared minus 7 times negative x plus 2. All right, negative x squared is just 4x squared. Negative times negative is a positive 7x, and then plus 2. So after reflection in the y-axis, this function should be 4x squared plus 7x plus 2, which should be number 3. Now let's try this one. Consider the function g of x equals negative x squared plus 4. What two transformations have occurred to the graph of y equals x squared to produce the graph of g? Specify the transformations and the order in which they occurred. Note that there exists more than one correct answer and graph it on your calculator to verify. Okay, so we are going to take g of y equals x squared and we want to turn it into negative x squared plus 4. Okay, so what transformation could have happened? All right, y equals x squared. Well, this becomes negative x squared. All right, what does negative x squared do? Well, what happened to that? We negated the function, correct? So the first one, it would have been negated the function because if it was in the parentheses, it would be negative. It would be positive, excuse me. All right, so we would, if we negated the function y, we are actually reflecting in the x-axis. So the first one we would have done was reflecting the x-axis. Okay, so that would become y is equal to negative x squared. That gives me the negative x squared. All right, now what does the plus 4 do? Well, that means it's going to shift up 4. All right, so that's going to be y equals negative x squared plus 4. Okay, so let's verify it in our calculator. I'm going to do y equals x squared, the first one. X squared. All right, then we decided we're going to negate it, negative x squared, and then we're going to shift it up 4. Negative x squared plus 4. Let's see if it worked. Okay, and I'm going to put this last graph up here and make sure that's correct. All right, we have here, and we have there. Okay, so let's see. Reflect on the x-axis was the first one. So we took the blue graph, reflected in the x-axis, it becomes the red graph. And then we shifted it up 4, becomes that. So that worked. Okay. All right, now to verify this, let me put negative x squared plus 4 in a different color just to make sure that we have the right one. Okay, negative x squared plus 4. Yep, that's the right one. So there we go. We have it. Okay, let's try another one. All right, is this the only way that we could have done this one? No. What if we tried it another way? All right, so we started out with y equals x squared. Okay, we want this to be negative x squared plus 4. So what if we did a shift first? But with the negative on here, we know we're going to have to reflect in the x-axis eventually. So if I did the shift first, what way would I have to shift if I'm going to have to negate the whole thing? Well, what if I shifted down 4? Okay, so that would be y equals x squared minus 4. Then, what if I reflected it in the x-axis? All right, so that would mean negate that, so that's going to be negative x squared minus 4 becomes negative x squared plus 4. All right, now let's see if that works in the calculator. All right, so this time we're starting with y equals x squared. We are going to move it down 4 first. So it's going to be x squared minus 4, and then it's going to be negative x squared plus 4 to get to the value. So let's see if it works. Okay, so I'm going to graph this. There's my original x squared. There's shifted down 4, reflect on the x-axis, and that's the correct one. So it works. Okay, so you can see there is more than one transformation that'll work for this when you do these kind of problems. All right, so let's leave exercise 6 for the next class and see if you can do those yourself. What you're going to have to do is each of these graphs, you're going to do a negative f of x and you're going to do f of x. So this is negative f, this is f of x. See if you can graph them and figure out what the equation is going to be. Okay?